Okay, here's an example of depreciation expense. So I'm recording the solution for one of the homework assignments. It's exercise 10-6. And I've added to this some additional examples beyond what the homework asked you to do. So something similar to what I would ask on the exam. Okay, so the question is in the textbook that this Rotini company is purchasing a new machine. They're purchasing on October 1st, 2017. So since this is purchased on October 1st, it's going to be a partial year. So watch that because it's not necessarily partial year on the test. I don't remember if it is or not, but watch the purchase date. The cost is $150,000. The company is estimating a salvage value of $12,000, and the machine has an expected life of 5 years. So the expected life will be used for 5-year life will be used for straight line, and it will be used for double declining balance. And they also say it has expected life of 10,000 working hours. Now the 10,000 working hours will be used for units of activity. So they're asking you to compute depreciation expense under straight line, units of activity, and declining balance. Then I'm asking you to do this additional step, which is similar to what I would ask you to do on the test. So first step, we're going to do straight line. Now remember, the formula for straight line is the cost minus the salvage divided by years. So the cost of 150,000 minus the salvage of 12,000, that gives you something that's called the depreciable base or the depreciable cost. We then divide that by the number of years, so the useful life. That will give us the calculation of depreciation expense per year. So this number is the depreciation expense. Now, in year one, 2017 is what they asked for. We only owned it from October to December. So 3/12 of the annual depreciation would be the depreciation expense. So the journal entry for this would be a debit to depreciation expense and a credit to accumulated depreciation. All right, so the next one they asked us to do units of activity method. So units of activity looks very similar to straight line. So once again, it's cost minus salvage. That gives us our depreciable cost or our depreciable base, and you divide by units. So in this case, it's 10,000 hours or 10,000 working hours. So again, our depreciable base, it's $138,000. So we're going to depreciate over the life, the useful life of the asset, $138,000. So if the asset is fully depreciated, so at the end of its useful life, the book value, and remember, book value is the cost minus accumulated depreciation. Okay, so often I ask you on the test, calculate the book value, and you need to know how to do it. It's cost minus accumulated depreciation. So if an asset is fully depreciated, the book value should be equal to the salvage value, because if it's fully depreciated, you would have depreciated the depreciable base. So in this case, that's $138,000. So cost of 150 minus 138,000, which would be this depreciable base, would leave you with the salvage value. So if they told us, so when we calculate this, it gives us the per hour or per work hour cost. So it's telling us the rate is $13.80 per hour. That's what the depreciation is accumulated at. So in 2017, The machine ran 1,700 hours, and our rate is $13.80 per hour. So the depreciation expense that will be recorded for 2017 is $23,460. So if more hours were worked during the year, your depreciation expense is higher. If few hours are worked, the depreciation expense will be lower. So it doesn't matter if 2017 was a partial year or not. All that matters is how many hours the machine ran. So we don't really care when it was purchased. All we care is how many hours the machine ran. So you don't change the calculation. Now, what's important to remember is you calculate this number and then you use that rate for the rest of the life unless they change either the expected number of units that will be produced, or they change the estimate of salvage value. So unless they make a change to the estimate of the unless they're changing their estimates about the useful life or the salvage value of the machine, you would use the same rate until the machine has been fully depreciated. Okay, and then double declining balance. So double declining balance, you're going to have the beginning of year book value. Okay, so you have the book value. You have 2 times the straight line rate. So straight line rate is 1 over the number of years. Okay, so in this case it had a 5-year life. So 1 over 5 years is 20%, and we're going to multiply that by 2. So 2 times 20% is 40%. So we use 40% every year over the life. So the book value at the beginning of the year times 40% gives us the depreciation expense. So we need to accumulate the depreciation expense year over year to calculate the book value at the end of the year. The end of year book value becomes the next year's beginning of year book value. So in the year we purchase it, the cost is the book value. So at the date of purchase, the cost is equal to the book value. Multiply it by 40%. Now, again, we purchased this in October, so the first year is a partial year. So when you multiply 150,000 times 40%, you get $60,000. But we didn't own it the whole year, so we're going to use 15,000 instead of 60. So accumulated depreciation at the start of the first year is 0, and we add the 15,000 to it, so we have accumulated depreciation of 15. I always calculate by taking the cost of 150 and subtracting the accumulated depreciation. And one reason is because then I can do this math and just go right across in my calculator, and I don't have to type any numbers, retype anything in. So I don't make mistakes because I can go across and then I can change the sign of this to a negative and then add 150, and then I don't have to retype anything or clear it or anything like that. The other reason is that if I'm using this number, you have to be careful if you're trying to get to this number, you have to be careful that you're adjusting this by this number, not by the accumulated depreciation. So it's easy to make a mistake if you're trying to go from here to here. You don't adjust it by this, you have to adjust it by this. So the next year, the 135 carries over to the beginning of the year book value, multiply by 40%, which gives us the 54,000. So 135,000 times 40% equals 54,000. 15,000 plus 54,000 is 69,000. 150,000 minus 69,000 equals 81,000. So the cost of 150 minus the accumulated depreciation equals 81,000. 81,000 carries over to the beginning of the next year. And so the problem asked us to calculate the 2018 depreciation expense and the 2019 depreciation expense. So the 81,000 times 40% gives us 32,400. So accumulated depreciation will be the 69,000 plus 32,400 equals $101,400. And then if you change the sign on this to a negative and add 150,000, that gives you the ending value of $48,600. That becomes the next year's beginning book value, which you multiply by 40%, gives you depreciation expense. Add to that 101,400, gives you the 128,40. Change that to a negative and add 150,000, gives you the 29,160. And then you just keep going. So this would need one more year. This is 1, 2, 3, 4, 5. Yeah, one more year because it's a 5-year life. And the first year is a partial year, so the last year should be a partial year. And you can see in the last year, we're trying to get this to 12,000. So the last year is probably going to be an adjusted year because 40% of 29,160, if we take 21,960 times 0.4, that's $11,664. And if you subtract that from this, what's going to carry over, oops, wrong one. So what'll be the beginning value is 17,496 times 0.4 would give you almost $7,000, and that would bring you down to a book value of 10,000, and you want the ending value to be 12,000. So we're going to take out what we need to take out to end up with $12,000. So the depreciation expense is going to be what, 5,496. So this is going to have that star there because we're going to plug the number so that we end up with the ending book value being $12,000. And that would be the depreciation in the 6th year, which would also be a partial year. Okay, now this section here, I said, well, what I want you to tell me is the accumulated depreciation and the book value at the end of 2019. So we did that for the double declining. So we, if we go back and look at the screen, oops, I can't go back. Okay, well, we did all the lines for those years. So for straight line, if I want to know what's going on for 2019, well, okay, in 2017, we did the calculation. 2017 was 3/12, so we took a partial year. 2018 was a full year. 2019 is a full year. So when we add those up, the accumulated depreciation would be 62,100. And the book value will then be the cost of 150,000 minus accumulated depreciation. So the book value is $87,900. So that's really straightforward. So if I ask you what's the depreciation expense in 2020, depreciation expense is $27,600 because it's going to be the same for every full year. So that would be 2018, 2019, 2020, and 2021 because it's a 5-year life. So there'll be 4 years that are full years, and then you'll have 1 year. 2017 is a partial year, and then the last year's a partial year. For units of production or units of activity, really what you're doing is you keep going until you get to the 10,000 units. So if I told you in 2019 the total hours we've reached are 11,000, you have to look at it and say, oh, well, we can only depreciate the first 10,000 hours. So you have to cap it at 10,000. So at the end of 2019, the total accumulated depreciation needs to be the depreciable cost. And the depreciable cost would be 150,000 minus 12,000, or 138,000. So your total accumulated depreciation at the end of 2019 should be 138,000. How much the depreciation expense in 2019 would be depends on what the accumulated depreciation was at the end of 2018. So if I don't tell you that, there's no way for you to figure it out. I would have to say, well, the depreciation or the number of units, cumulative units at the end of 2018 was this. And if I tell you that, then you can tell me the expense for 2019. The book value at the end of 2019 is going to be the salvage value, because if it's fully depreciated and we figured out the depreciation rate, assuming there's a $12,000 salvage value, the book value has to be the salvage value. Okay, that's it.